All right, we are live, and thanks everybody for joining us online. We've got a nice group of people here in Research Triangle Park in North Carolina, and today we are joined by David Johnston, who is the chairman of Factom. And Factom is a pretty unique company. I think one of the first, if not the first company that really started commercializing like time stamping of blockchain and thinking of blockchain less, I guess, as a currency and more as a new type of database. And we're definitely interested in hearing all kinds of unique applications of this technology here. And I'll just go ahead and let you take it away, David.
Cool. Hey, everybody. I'm glad to be here today. And yeah, happy to speak about Factom. I want to try to keep this pretty interactive. You know, I know we got a lot of smart people there in person. So I'll just speak for a few minutes and then really open it up for questions and discussion. I enjoy that part a lot more. Yeah, just to speak to the vision and the history of Factom. A lot of you guys probably know that Factom started out in 2014 as a white paper that Paul Snow proposed to basically create a data layer on top of the blockchain, right? Because what I challenged Paul with was, hey, how can we do huge enterprise level applications on the blockchain? And his feedback to me was, well, before you can do that, you just need to be able to establish identity on a blockchain, right? We need to get past think of things as transactions or payments, but instead thinking about how we can secure identities on the blockchain. And he worked on that for a while, and what he came back with was really, even before we can build identities, we have to have a generalized data layer where we can validate any type of data, right? So Factom is data agnostic. You could publish JSON or plain text or encrypted text, or a lot of people publish hashes in the Factom blockchain. And so that was his insight that, okay, in order to make blockchain scale, we can't shoehorn all the data directly into an up return metadata field in a Bitcoin transaction, right? We need the real data structure. So the way Factom is designed is this Merkle tree structure where you can publish all of the data. You have a unique chain ID for your particular chain of entries. And the beautiful thing about that is every 10 minutes, Factom can aggregate all the information submitted to the Factom network and boil it down to a single Merkle root, which is what anchors into Bitcoin, or we've coded up so it can anchor into Ethereum. So that core concept has allowed us to go into production. We launched in September 1st of 2015, and since then 100 million records have been secured to Factom, but we only had to publish 80,000 anchors, which is the number of 10-minute periods since September 1st, 2015, right? We could have secured 100 billion records, right? It scales as much data as you want to put into that Merkle tree. It's still only taking us one transaction every 10 minutes to anchor that information to the blockchain. So anyway, that was Paul's moment of genius, was to say, okay, this is about securing all sorts of data, and to do it at scale, we really need a second layer that's going to organize all in this information in a way that can be efficiently anchored to the blockchain. And more than that, when you want to come back and validate your data, you don't need to validate all of the information in Factom. You only need that Merkle root that was published in Bitcoin, your particular directory layer, and your chain ID and your entries, right? So you can imagine out of gigabytes of data, you may have 100 megabytes that you really care about and that you want to validate. So that was his insight. And yeah, we've spent a lot of time since then really focused on enterprise use cases, and we've been approached by hundreds of enterprises since 2015 wanting to use the blockchain, but when they could only do a few thousand transactions a day, it was really limited to proof of concepts, right? So they saw in Factom the first opportunity to do something that they could put into production. So even now, as far as I'm aware, Factom is one of the few protocols that is serving large enterprise use cases in production. So we've had the fortune to work with folks like the Bill and Melinda Gates Foundation. They have a use case around medical records. There's been public press releases about our work with DHS, and a number of banks and other groups that we're actively working with. So that's sort of been the evolution, is creating that second layer that provides scalable data on the blockchain. And then since then, we've been building software on top of the Factom open source to serve particular industries. Because one of the big questions that came up was not just, okay, we can put data on the blockchain, that there's so many things you can do with that. What's the most valuable thing that you can do with that, right? That had to become our filter for, okay, we're gonna focus on users basically with the biggest pain point, right? So you end up talking to these enterprises that, you know, they're not trying to do a small optimization around their existing digital system. A lot of times they're still in paper systems. And what you're competing with is, these are solutions that can replace paper. Because once you talk to a lot of these enterprises, you realize that a lot of them are still using paper in 2017, not because they don't have software systems, and a lot of what they print out is actually originated in software systems, but they don't trust their own databases, right? But they trust that if they print out a piece of paper and they put it in a warehouse, it's really hard to change that record, right? They have much more confidence in atoms that they printed on physical paper than they do in electrons in their database. So that's a really big distinction. Is Factom's goal in part is to give the same level of confidence that they have today in paper to digital records, right? Because as soon as you're anchoring this data to the Factom network and to the, by extension, to the blockchain, you would get time stamping, as you mentioned. You inherit essentially a tamper-proof layer, right? You can really build robust audit trails and cryptographic proofs that show, yes, these are the records and they're unchanged from when they were published. But not only that, a lot of people only investigate Factom to sort of this surface level where they think about it as time stamping and proof of the positive. A lot of times I like to bring out the fact that there's something much deeper going on, which is Factom extends proof of the negative to this data layer, which is really critical. I mean, I'm using proof of the negative, but in the Bitcoin vernacular, it's usually referred to as protection against double spends, right? So not only knowing that the transaction happened and that it's valid, but it's the only valid copy is really important. And so in Factom world, it's not only that you timestamp these documents and you know these 100 documents are valid, you know there's only 100 valid documents, right? So if you're doing accounting or auditing, this sort of things becomes really, really important. Because if you hand me 99 documents, I not only know that they're valid, but I know that I'm missing one, right? Which is a much harder problem in computer science to solve, is not only knowing what you have, but knowing what you're missing. So Factom really tries to approach that problem by creating these data structures that make it easy to determine identity, who's publishing what in their particular chain that they've created, because they're associated a chain ID and a digital signature with those entries that they've published in Factom. And you can have a level of confidence that, you know, I can validate that data and know that it's the only valid copy. So it's more than just proof of the positive. You really need that additional ability to prove the negative and that you've got the only copy. So we've spent a lot of time thinking and working on that, and I think that's part of what has attracted a lot of enterprise groups, is they need really robust tools around auditing and accounting and record keeping and documentation. And so this is a whole new thing for them, where, you know, you can almost think of these tamper-proof databases not as something that can't be changed, but that's append only, right? You can't pretend the history didn't happen. So anyway, that's just a quick introduction from a high-level view. Is we're passionate about honesty and transparency, and we think the way that you get the whole legacy enterprise world there is you build a set of tools that integrate with their existing tool set, right? So instead of trying to get them wholesale to adopt an entirely new and different system, we're basically saying, look, guys, you can take your existing systems and augment them with this tool and create all these audit trails of what you're already doing, and then know for sure later whether you followed the right process. You know, it makes it easier to find bad actors if somebody's trying to change data for the wrong reasons. So that's sort of been our approach during this period, is to go through that process of onboarding and educating enterprises that there's a way to do this that essentially brings all of their existing systems onto the blockchain without saying, okay, we're going to do the heavy lift right now, which might take the next 5 or 10 years to replace all your systems with a full blockchain solution. So we sort of see this as a big first step for enterprise in order to get their toe into the blockchain ecosystem. And then once they have these audit trails, once they have secured their data to the blockchain, then it makes it a lot easier for them to start building new systems and processes that rely on that. So anyway, I don't want to make this too long-winded. I'll just start with that as an introduction, and welcome questions and you know, what you guys are curious about.
Cool. So I definitely understand you know, the concept of putting data into a blockchain, you know, creating some audit trails seems fairly straightforward. Do you then take the next step and create tools for these companies to be able to automatically check the audit trails? You know, like how does that come into play to actually make use of the immutable data that you're storing?
Well, yeah, absolutely. Recently, earlier this year, we announced Factom Harmony, which is basically a user interface for our enterprise customers that makes it super simple for them to check that all the documents are valid. So it removes all the complexity, right? They're not even thinking about it as publishing entries and checking them. They literally see, you know, is there a green check next to the document in my file system or in my document management system? So they can log in and they could say, I'm gonna drag and drop this file in, and yes, I already have a copy of that, and yes, that was timestamped as part of the origination process, and I'm already good on that front. And so we've made the user interface very, very simple. And what a lot of this is being done is being done in the backend, right? Because their system is connected to a series of APIs, right? It's not that they're manually dumping in documents as they go. It's just they already have a backend system for all this document management. And this is a new set of APIs that publishes the hashes and the metadata and the surrounding information about those documents to Factom and secures it in the blockchain. And then they can come back later when there's some question, right? Give you an example. In the mortgage industry, about 1 out of 10 mortgages is audited every year. Maybe it's because it's being sold, maybe because it's a regulator, maybe because, you know, the customer has some question. Whatever reason the file is being audited, they can then go open that file, and instead of spending hours with what they do today, comparing PDFs and database entries to make sure they've got the right copy of this, right? They'll know right away, okay, here are all the documents and I've got all the valid copies, and I can see none of this has changed over time.
And so you said you've been working with enterprises. Haven't you also been working with some governments? Wasn't there some sort of land registry program or something like that you were working on?
Sure. We've been approached by a number of groups. One very early on was in Central America, and they want to do an announcement around land titles. And so went through the process of figuring out a proof of concept we could do with them. Surprisingly, governments are turned out to be very slow in implementing, and so that's sort of one of the early learnings was, wow, okay, government cycles are like 5-year cycles, and we ought to really focus on the private enterprise because their cycles are like 6 months or 12 months. So yeah, we've seen a lot of interest in that use case. One of the challenges in that particular use case is it's a garbage in, garbage out problem, right? So if you put poor records in, you're just time stamping and making immutable poor records, right? So the thing I think where it can add to that use case is it increases the level of accountability, right? Because all of a sudden, you publish something before and, you can't really show who put it in there. But all of a sudden, if there's an immutable record, it's a great way to find bad actors or at least keep people accountable that, okay, what you publish in here, just know that we're going to forever know you were the one that published it and that this was the version that went in at this time and you're signing your signature to it. Because there had been a lot of problems, and there still are a lot of problems in Central and South America around people changing titles and things like that. So all of a sudden you can create a level of expectation that, okay, whatever I publish in here, it's for good, right? I'm going to go in knowing that. But there's still a lot of levels around and a lot of complication around sort of fractured record keeping there that are maybe the bigger pain point versus the immutability. So, and we've seen a lot of that in the United States. For instance, there's something like 5 or 10,000 different municipalities in the US that all keep local records, and some of them are digital and about half of them are not, right? So it's a big lift to try to take all those fractured records and build value with them. So what we've ended up doing is focusing more on use cases where there's a gap in trust, right? So today, for example, in the mortgage industry, it's something like 45 days to transfer a mortgage asset, right? Like the trader agrees, yes, I'll buy that mortgage on the secondary market. 45 days later, it transfers. And most of that time in between is they hire an auditor and say, I want to know that it's A+ grade that they told me. I want to know that I'm not inheriting any liability, right? Because after the financial crisis, none of the banks want to inherit any liability from any other bank, right? They got burned to the tune of $16 billion in fines, right? So they're very sensitive about the idea of inheriting liability. So anyway, those are the use cases where there's I think the biggest pain point that we've found. And so we're trying to focus on those areas where it's really, really clear it can add value. If you go from 45 days to any fraction of that, you're adding a huge amount of value in that transfer process.
Gotcha. So, we're creating these quote unquote immutable databases, and we're basically, at least in the public permissionless space, we're kind of coming to an agreement with other people that this is the authoritative record for whatever. And It seems like it would be fairly easy to go into enterprise and manage to get small groups of enterprises to agree to use this quote unquote authoritative trustless data store. But then when you're going to a government, is there like an additional hurdle there to get them to recognize it? One thing that I was kind of shocked by is we had Monax present here for about a year ago, and they're doing legal smart contracts, but they're doing dual style contracts where it's a smart contract, but it's also a old school legal contract, and they're combining them together and like putting them in the blockchain. And they basically said that, there are already some precedents in court systems that show, if you can bring in the expert witness who knows about blockchain and all this stuff, then the courts will generally accept this as an authoritative record. So have you found like a similar type of thing with governments?
Yeah, I mean, fortunately, a lot of the groundwork has already been laid with the laws and precedents around digital signatures. So middle 2000s into the early 2010s, almost all, I think all 50 states have passed a law or regulation that recognizes digital signatures. So, and there was a federal law that came before that. So there's been a lot of groundwork already around, yes, we realize digital documents are a thing and digital signatures are a thing, and we're recognizing them in law. And what I would propose is what we're doing is the same. I mean, they're literally the same digital signatures, right? The technology for blockchain is just a means of distributing those signatures, right? It's a means of giving everybody a copy of those signatures, but the math and the technique for doing digital signatures is virtually the same, right? And so I think we can pretty easily build on top of that existing precedent, seeing any pushback to say that, oh no, this is fundamentally different for XYZ reason. So I'm pretty optimistic that the groundwork has already been laid on that in that respect.
Yeah, we'll have to get a line here of people with questions since the remote microphone isn't working. So you're up, buddy.
All right. How's it going?
Hey.
Why did you feel the need? Now, obviously, I don't know when you started Factom. I haven't researched that yet. But why did you feel the need to start your own blockchain, as opposed to use another blockchain for a really record source?
Right. No. That's a really good question. And I've, before this, run, the BitAngels, Angel Network and the dApps Fund. And I talked to literally several hundred entrepreneurs. And a lot of times when people told me they needed a blockchain, I said, why do you need a blockchain? And a lot of times they couldn't give me a compelling reason they really needed one, right? But I've seen exceptions, right? So when Vitalik and I were first talking about Ethereum, it was clear that he had a strong set of reasons because he wanted something that was Turing complete and a broader set of scripting languages, that there was a lot of value in creating Ethereum and not just trying to shoehorn it directly on top of Bitcoin, right? He tried to do that before Ethereum, right? He contributed a number of colored coin related projects, Mastercoin, things like that, but realized pretty quickly the limitations of the existing scripting engine on Bitcoin and the need to start something totally fresh. So when it came to Factom, Paul and I had that conversation pretty early on, along with Brian and the other founders, like, do we need our own blockchain? But with the architecture that we built, and this is back in 2014, when we were publishing the white paper, that there wasn't anything available that created the data structures that we needed, right? And in a way, we're basically building on top of Bitcoin because that's where we're inheriting all our proof of work. To be clear, Factom has no miners. Like, there's nobody burning electricity to secure Factom. We're inheriting all the security from Bitcoin because by publishing that Merkle root in Bitcoin, the Bitcoin transaction hasn't changed, right? Because there's all the proof of work behind it. Okay, if I know that, then I can go up to the Factom layer and say, yeah, well, if I know the Merkle root hasn't changed, then I can validate all this data higher on the data tree and say, yeah, this particular branch is valid because I know it matches what's in Bitcoin, right? So it was a clever way of harnessing all that proof of work and doing it in a way that was really efficient, but you still needed a distributed set of servers, and anybody could run a Factom node, right? It's an open source network, but you needed a neutral way to distribute all that data. Because the truth is, none of the banks or other people want to work on their competitor's system, right? So something that was private wasn't going to work. You needed a public, neutral platform where you could publish all of this data, and it wasn't going to be owned by one of those players. So the answer is basically the structure for the data architecture didn't exist, and Factom was one of the first to do it. And what I want to draw one more distinction is it's not about storing data. Factom is not an efficient way to store data. It's an efficient way to secure data, right? And that's why mostly people are publishing hashes, right? Because it's storage agnostic, right? You could be storing the data on, Safe Network or storage or AWS or whatever your favorite flavor of storage is for the raw document. But as long as you have a copy of that, you can recreate that hash and prove that that private information hasn't changed because I publicly published this audit trail, right? So that's been our approach, is be agnostic about where the data is stored, but offer a platform where it can all be audited and secured.
Yeah, I like to say that Factom's blockchain is basically anchoring into Bitcoin's blockchain, and that's kind of how I see a lot of this large ecosystem of blockchains working. Is I'm not necessarily a Bitcoin maximalist, but I do believe that Bitcoin has some of the greatest computational power behind it, and
right.
If you can harness that by just putting little anchors in every once in a while, it doesn't matter what you're doing in any other system, you can still gain some benefits there.
Yeah, absolutely. A big fan of Jeff Garzik, and he beautifully described this as Bitcoin being the root of security.
Yeah.
Right? Not everybody needs to burn tons of electricity. Just use Bitcoin as the root of that security model. Yeah.
Very cool. What is one more follow-up question? Are we still on?
Sure.
Yeah, we're still on. So in terms of, you're going after Fortune 500 you've talked about there's a variety of industries that are, some are more paper-based than others.
Yep.
What do you see as the, just quick tidbit, lowest hanging fruit industries out there?
That's a good question. I would say it's areas where costs per record are really high. So that's sort of where this is most valuable. When you look at use cases where there are billions or trillions of, sensor data, data points that could potentially be published, the value per entry is really low, right? Okay, I have this, temperature sensor, and that might be interesting in the aggregate, but the per sensor reading is not very valuable. And so, we've ended up focused where securing the data is most valuable. So you think about assets like, homes and land and all the rest of this. Like, these are like $250,000, $500,000 assets that are secured by 1,000 documents, right? So the per document value there is extremely high. And so, you want to focus on use cases that are really worth solving. A slightly more, redundant temperature sensor, data point is, I guess, novel, but, not really compelling to the person that, lost their home in the financial crisis. Like this is really meaningful, right? We're in like a crisis in the US. I mean, homeownership is at a 50-year low. And a lot of that has to do with, for the banks, it's not really profitable to do mortgages much anymore, right? Because the cost of their compliance and regulatory burden, it like tripled. It went through the roof after the financial crisis. So for every mortgage they generate, they're spending thousands and thousands of dollars, and that's no exaggeration, per mortgage on auditing and the back end of all of this. And so it's just such a huge cost that, all right, we'll give mortgages, but it's only people with 800 scores and perfect records and, jobs over 6 figures or whatever. And so, considering home ownership is something that makes up the majority of most people's net worth and savings, the idea of fixing some of that overhead and making it more accessible for millions of people to own homes because it's more cost efficient for the banks to do all of this compliance, that's a real world impact that like matters. So anyway, we're going after use cases where we see a clear vision for that.
High ROI, I think, is a good TLDR there.
Yeah. Next question. Hey, David. My name is Jeffrey Ritter. I actually teach at the University of Oxford courses on digital trust, as well as everything you've been talking about today in terms of blockchain innovations. One question for you. To get ecosystems of companies to accept the immutable status of a particular record usually requires agreements among those companies. When we look back at the development of EDI networks and the hub and spoke magnification and growth of EDI in the 80s, one of the key things was who wrote the contracts. And we saw that the major hubs, including IBM and General Electric Information Services, ended up sponsoring the agreements that the parties used to trust the centrally stored archived record. Everything you're doing makes so much sense, especially your experience in looking at mortgage, your understanding that internally the enterprises don't trust their own systems, great insights and great momentum. But how do you deal with the contract question? What we found in the 80s was that the best way was for the parties that may have to mutually rely on those agreements, and it could be quite a lot in a supply chain, that they're agreeing to treat a Factom authenticated blockchain secured record as the record, and they will not protest the validity of that record against one another. That seemed to be a very positive strategy. Have you been looking at that, and what is Factom doing to package the contract that helps the technology scale?
I think that's a great question. And a lot of this knowledge, I have to give credit to our subject matter expert, Jason Nadeau, who spent the last 25 years in the mortgage industry building software and selling software, and then as part of those large companies running a lot of these enterprise software packages. He built a company in the 90s and the 2000s, ended up exiting it to Black Knight Financial Services, which is one of the big groups that does these back-end services for the banks. And, you know, I think his approach has been great, which is we're not just talking with the banks, we're also talking with regulators and others that set a lot of those standards, right? And what we hope to see is, you know, when we present at the Mortgage Bankers Association or other events like that, is a set of standards emerge which really embrace this technology. And fortunately, because of the way that blockchain works, is in the situation you're describing, you had a central party, and the data that was done before somebody joined the consortium, they just had to trust that process that had been followed. Fortunately, because Factom serves as a public witness, and we're anchoring this into a public blockchain, when some new group joins the consortium, they can validate the data all the way to the beginning of history.
Right.
And they don't need to take that leap of faith when they join the consortium that things done before they were looking at all the records are correct, right? They can actually just validate the math. So we think that's a pretty good approach. And there's a lot of good, as you know, existing standards for some of this data formatting and metadata around the mortgages and these different assets. And so we're trying to leverage that versus reinvent it.
Good answer. I think you're going to find that governments will be receptive to accepting a blockchain secured record if the industry participants are accepting it, and the standards become vital. We're certainly seeing that in cloud security. Thank you very much.
Yeah, absolutely. And just to add on to that, the funny thing is, once you get past, you know, the novelty of the technology, you end up talking about just what it does, right? And people forget that it's even a blockchain solution. They're just excited about the immutability and the real-time audits and all of the actual features that come along with that. And that's why I think we're seeing so much of a change in the view of the regulators. Honestly, this is their dream, right? The ability to do granular audits and see things in real time instead of catching them 3 years later. You know, it's really going to change the way they can view the whole industry.
Agreed.
Yep.
Thanks for coming in and talking to us today. Appreciate it. My name is Cody, and I'm not nearly as smart as the last guy, but I do work for one of these big audit companies that you are helping out, KPMG. And I guess my question to you is, you've mentioned specific use cases of like mortgage verification. I guess my question would be is, do you see applications for financial statements? So most companies have either an ERP system in place. Do you guys do any kind of work in that space? And if it's not for an entire system, an accounting system, if you will, do you have specific use cases for companies at a smaller level, maybe intercompany transactions or anything like that?
Those are certainly interesting. And what I would say is Factom Harmony, we're building it not just as a solution for mortgages, but as a platform for documentation, decision preservation, right, evidence preservation, these aspects where, okay, I want to, you know, I can apply that to different industries and different clients and not just mortgages, right? Because it turns out document management is a pretty common problem among a lot of clients, right? You know, everybody's not great at keeping track of these things, or they have duplicates, or they have these similar problems. So we've ended up building it so that it can be applied to a few different use cases. But to your question about transaction, I would say the use cases that are most interesting to us are the ones that are unique, right? So a lot of people in this space tend to focus on trading, right? I'm going to put gold trading on a blockchain or securities trading on a blockchain. And that's interesting, but when things all sort of look the same, you know, the same ounce of gold, right, is pretty fungible, the same barrel of oil is pretty fungible. That looks more like a coin-shaped problem, right? And that's sort of where people started. What we've tried to change in that mentality is there's a lot of problems that don't fit into that bucket, right? Call them non-fungible assets, right? The mortgage that I get, right, is based on a different house with a different lender, with a different borrower, with a different payment history, with a different title, right? It's a very unique asset, every one of them. And so I think Factom is most useful when you have a unique asset, you have a lot of documents associated, right? Anybody that's been through a mortgage process knows how many pieces of paper are involved in this that describe that one unique asset, right? So I think those documentation intensive things are really key for us. So in the mortgage industry, for example, I think it was last year, 1 trillion pieces of paper were created related to those 10 million mortgages that were issued last year, right? So that's the level of documentation that we're talking about. So I think that's a good indicator of whether it's a good use for Factom or whether it's something that makes sense on another solution. I'm big on the fact that one blockchain or one protocol is not good for everything, right? I think we're going to end up with tech stacks where, you know, if I want to transfer value, I can use Bitcoin. If I want to write a smart contract, I'm using Ethereum. And in fact, what we announced last year was an example of partnering with smartcontracts.com. And so you can write an Ethereum contract and trigger it with data on Factom, right? Because the contract has to be aware of some event in the world, right? And what do you want? You want a time-stamped, immutable oracle of those events. And so those are an example of something you can publish in Factom and trigger a smart contract. So I'm really interested as we see more interactivity between the different protocols and systems as they mature, and we end up, you know, I don't like to be tribalistic, like, oh, ours is the greatest protocol. It's good for a set of things, right? It no more than I would say a particular programming language is the be-all, end-all. It depends on what you're building, right? If I was going to build a website, I would use Node.js or JavaScript or whatever. You know, I wouldn't use Golang, right? But if I wanted to build a backend for an exchange, I would go with a language like that. So I think something similar will evolve in this space where we're thinking about all these different components I can use to build these solutions.
Very cool. I guess just one little slight follow-up is, so do you know of anyone in this space that's kind of doing something similar outside of mortgages for, I guess, accounting records or I guess just transactional level?
There's a few groups that are focused on that. Certainly, if it's accounting systems, they're pretty unique use cases. So I'm not excluding that from the bucket of things that are fairly unique. And I think there's a lot of record keeping involved there. So it's something we're interested in and we're talking to some enterprises about, but it hasn't emerged as a major focus for us yet.
Excellent. Well, appreciate it. Thank you.
Yep.
Thank you. Yep. Yeah, here I am. Hey, Mark Hutchinson. Did have a question, probably just confusion on my part. You had mentioned there was only one copy, and I thought that with blockchain, everybody had a copy so that you could run your verification, your hashing on your own copy of the data. So could you clarify that misunderstanding or how I interpreted your there's only one copy?
Sure, I think I can happy to clarify that. So Factom, like any other blockchain, is distributed, and everybody can download the full Factom ledger. So everybody has a copy of all the data on Factom if you want to download a full node. So that's the same architecture. What I was saying was, let's say go to the accounting system example. This is something that happens sometimes in the developing world, or even in the first world. Is there multiple copies of books, right? There's the books they show the tax accountants, and there's the books that they show their boss, and there's how do you know there's only one version? So with Factom, because you can create a chain ID, and because you can associate records that you publish with that chain ID, because you used your digital signature to sign the first entry in that chain, you can establish an identity, and you can say permanently, this is the only valid set of copies, are the ones that I'm publishing on this chain that I have signed. And what you're getting with that is you're avoiding the issue where there's another valid copy of the books over here on this chain I didn't show you, right? And so you know that it's not only valid data, because how do you know I didn't publish 10 different versions, right? Well, by associating an identity and a long-term identity, right, I've etched in stone, if you will, that information, and I'm building on that identity and reputation as I continue to set records in that chain for a long period of time. So it makes lying very expensive, right? You can't prevent bad actors, but you can make it really expensive to lie, right? And so people tend to lie about the past, not the future, right? I don't know what lie I'm going to need to tell 5 years from now, right? So I just do what I do today, and I'm not necessarily building toward some false future. People tend to lie about the past, and so that's what I was trying to get across. Is Bitcoin has this magical thing where I not only know that the Bitcoin transaction is valid, that I've got the only valid one, right? The double spend problem is two people show up at the same time and say, I have a claim to those Bitcoins, and both try to spend them at the same time, right? And the Bitcoin mechanism has a resolution of that. The consensus mechanism only recognizes one Bitcoin transaction, right? And so in the same way, you have to have the right digital signatures and all. In the same way, Factom extends that proof of the negative, that there's only one copy, one valid copy, to all of this data that's published on Factom.
Okay. Hi, David. I'm Dave Warner.
Hey, Dave.
Question for you about, you mentioned that Factom uses the Bitcoin blockchain as a level of security. I'm curious how Factom is dealing with the upcoming upgrades and the addition of segregated witness into Bitcoin.
That's a good question. Probably direct you to Paul Snow. I think he's posted some stuff on the Factom subreddit with the details. But my understanding from the developers is that we're continuing to anchor into Bitcoin, and given the way the systems are, there may be some crossover for a period in time. For Factom, we're blockchain agnostic. We're not trying to only anchor into Bitcoin. We've coded up the anchors for Ethereum. We may well anchor into to Bitcoin Cash. And this is something we had to adapt pretty early on, because the question always comes from the banker, well, what happens when Bitcoin goes away, right? And I find that a very unlikely scenario, but you have to be able to respond and say, not a problem, we can anchor into Ethereum. Well, what if Ethereum goes away? Okay, well, we can anchor into Ripple or Stellar or whatever, right? The point is, we're agnostic to one particular blockchain. We're extending the immutability from the blockchain. But the nice thing about anchoring into multiple blockchains is sort of a belt and suspenders strategy. Like, at some point, literally the internet would have to go down before you couldn't validate the data in some large blockchain, right? So you add a lot of redundancy, because the anchors we're publishing, it's all the same Merkle root, right? We're not creating a different Merkle root for each of these anchors. It's all the same Merkle root. So it's like publishing this proof in the New York Times, right? The New York Times happens to be distributed all over the US and all over the world, and people can find a copy and say, yes, I can prove, this is unchanged. And so that's sort of the way you have to come back and say, we're blockchain agnostic. We're betting there's going to be a future where blockchains are around. That's a really high certainty statement, and that usually answers the question for them.
Okay, thank you.
Yep.
Hey, what's going on? I'm Jonathan City. I have a question about it sounds like a technical gap between the human factor and the immutability of the Factom blockchain. Okay. So if you have a Merkle root and the hash of the document, what is going to stop a bad actor from actually deleting the document itself? While you might have immutability from the hash, we don't have anything to prove it against. Do you have anything technically that will prevent that?
That's a great question. And some customers are inquiring about how we can, in parallel, do immutable storage along with what we're doing with immutable security, right? So there are a bunch of decentralized data storage networks emerging. I'm a big fan of the Safe network. There's storage. There's other groups. I think SIA is doing some of that. So there's a lot of groups. These are distributed hash tables where you're putting a copy of this all over the place, and whether one server goes down, right, it's redundantly stored in a lot of places. And so I'm a big fan of distributed storage. With that said, the way the existing systems work, like by law, a lot of these institutions are required to keep a copy. And if the copy goes missing, that in itself is a red flag, right? So there may either it was incompetence or it was fraud. Either way, they get slapped by the regulator. And that's a lot of what happened in the financial crisis. Is some of it, yes, was fraud, but a lot of it was sloppy record keeping. And imagine yourself as a regulator trying to look back afterwards. How do you tell the difference? They couldn't, right? So they basically slapped the banks with fines as if all of it was fraud, because they couldn't separate what was fraud and what was sloppy record keeping, which has led to all of this overhead. Okay, what the bank said is, okay, what we're gonna have to do is hire a ton more auditors, a ton more back-end people, and we're gonna check this 10 times before it ever gets issued, right? Literally 10 people are gonna look at it, and the checker is gonna check the checker, is gonna check the checker, is gonna check the checker, right? So because they didn't have a technological solution, they just ended up adding a lot of bodies to the problem, right? We're gonna hire auditors, we're gonna go to InfoSec, we're gonna outsource this, and we're gonna have a ton of people just manually look at the documents. But for Factom, what we can do for them for the first time is offer that same level of confidence just looking at the math, right? We can prove mathematically that this document is the same as this document. You don't need to hire the auditor to spend 10 hours looking at documents. They can see all the green checks. And if there's one that doesn't match, they see it right there and they go and investigate that one, right? So that's what we're trying to do, is just make this a lot more efficient.
Got you. Thanks.
Sure.
Hi there, Derek Smith. I just had a quick question. How is your solution different from open timestamps, and like, what do you do in excess of that service?
That's a good question. There have been a lot of different proposals that sort of overlap in one functionality or one aspect. There's been a lot of groups that do this sort of in a centralized way. I'd say one of the biggest differences is an open network and having guaranteed persistence, right? So because there's a Factom token, there is a monetary incentive that keeps federated servers interested in anchoring to the blockchain and to retaining all of this data, right? Because we talked about earlier, the big thing is that, well, if it's going to be everybody has a copy, you need a monetary incentive to have somebody to keep a copy of all that and be persistently on the network. And so obviously this has served Bitcoin really well. You need a monetary incentive for people to provide the proof of work to validate the blocks. And with Factom, it's very similar. Like, I've seen a lot of these sort of proposals come along where somebody says, oh, well, we don't need a token, we're just going to do it with this cryptographic solution. And this cryptographic solution might be great, but without the economic side to incentivize somebody to do this and keep up this network, what I've seen is just not a lot of adoption. Because the problem is bootstrapping these things is really tough. And to convince somebody to run all of this infrastructure is not a small thing, it's a big thing, right? Developers just want to be able to show up and hit an API. They don't want to have to run servers or run infrastructure, do a lot of this stuff themselves, which is the beauty of Bitcoin. Like, developers don't have to spin up all the nodes and all the miners themselves. It's just sitting there and they're ready to hit it with transactions. So that's the big thing I would say is it goes back to the same thing that I thought about back in the day when it was the original colored coin proposals. There was no token incentive, right? It was just a standard by which you could publish data into the network. Token, to incentivize that behavior, nobody was building wallets. Nobody was building exchanges. Nobody was building the infrastructure. And it was sort of just limping along. And all of a sudden, when Mastercoin came out and Counterparty and then Ethereum, there was this huge incentive to build that infrastructure. And so I think that you can't purely have a technological solution. You have to think about the economic part of it and couple them together.
Okay, thank you.
Sure.
hardball question.
All right, I'm back.
Sweet.
Following up on that, why do factoids, in your opinion, have value?
Factoids are a software license that allows you to publish data to the Factom network. And it effectively acts, along with entry credits, as an anti-spam mechanism. If in an open network, it costs nothing to publish data to Factom, people would just attack it, right? Somebody would try to publish 1 trillion entries, and all of a sudden it would be denial of service, right? So you need some cost, even if it's a small cost, to publish to the network. So factoids convert into entry credits, and entry credits publish 1K of data into Factom. They're one time, they get used up, right? So think of gas in Ethereum, right? You need to fund that contract, and you're proving that you're not a bad actor and you're spending some resource to publish this information. And it works out to like 1/10 of a penny to publish that 1K of data. And a lot of times people are publishing hashes and they're putting 10 or 20 hashes into this entry. That architecture is really important because without that, the attack vector, but also the way that we broke out factoids and entry credits is really important. Because most people, when they're building an app, don't want to hold a wallet and deal with all the security aspects. So the way entry credits work is when the factoid is used to convert into entry credits, it's assigned to one public key, one public address, and that can never be changed. So they're non-transferable. So if you broke into somebody's entry credit wallet, you could publish data to Factom, right? Like that's it, right? They can't be transferred. There's no token value there. So separating, bifurcating the publishing mechanism and the non-transferable token with the software license, the factoid, which floats with the market, also gave people confidence that, okay, no matter when I use the system, I can always convert entry credits, and they're always going to be about 1/10 of a penny, right? So there's a conversion rate between the factoids and the entry credits. So it's up to the market, right? Depending on how much usage of the system determines how many factoids are consumed.
Right. Follow-up question to that. Will your new platform, the one that's you're customizing for, I forgot what you called it, Factom
Harmony. Yep.
What will that be using factoids in some way, shape, form, or fashion? Yes.
Absolutely. So
absolutely,
as an application that's publishing data on Factom, it has a supply of factoids or entry credits. And for every document, for every hash that is published, it's doing all of that. The key is it's doing all of that in the background, right? The user doesn't have to buy factoids or worry about the conversion or handle the private keys or any of that. But the enterprise application just makes it as simple as connecting their APIs, and they pay a monthly subscription, right? So Factom Harmony is created by Factom Incorporated for profit, right? So this is proprietary software using the open source network, right? So our view is when 1,000 companies are publishing on top of Factom, that's a huge win, right? Is we want to build an ecosystem where it's not just us, but anybody can publish this data. And what I'd say is we're probably going after the most valuable use cases, right? You look at the App Store, and anybody can make an app, but Google and their Play Store, right, is going after Gmail and search and photos and all the use cases they think, the top 20 or whatever they think is most valuable. That's sort of our approach as well, is we want to keep this open and a permissionless innovation layer, but we built the system because we think we can build pretty cool stuff on top of it.
Thanks.
Hello, my name's Spencer. I just had a little question. I wanted to clarify something you were mentioning about Factom being anchored to Bitcoin. Now it's my understanding that Factom itself is blockchain. So what I want to know is, first of all, what exactly does that mean? And what are these other blockchains providing that your blockchain isn't able to do itself?
That's a good question. So I'm defining a blockchain as the literal connection of blocks of data, right? So in the case of Bitcoin and all blockchains, right, you're taking the header from the last block and you're including it in the next block. So you're linking them via these hashes and digital signatures, right? So that you can prove this series of things happen, right? That's the origin of the word blockchain, right? Beyond that, Factom is a peer-to-peer network. Anybody can join, anybody can run a node, they can, you know, provide a copy of all the records to anybody else. Usually these are customers that are using the software, right? So the banks want to know if Factom went away tomorrow, there's still a record of everything that they can validate against, right? I'm talking about Factom Incorporated. Like if Factom Incorporated doesn't work out, all of the data is still there. The peer-to-peer network is still there. The data validation is still there. The whole history of the ledger, right, is still there. So that's really important because they're not betting on this little startup, you know, being around forever. They're betting that this open source network will always be there and they can take their record at any point and validate against it, right? So that's an important distinction between, you know, oh, trust us with all your records, you know, we'll be around 50 years from now. That might not be true of a company, but it's probably true of a peer-to-peer network with a blockchain architecture. So it's got the open ledger architecture, distributed ledger architecture. It's got a peer-to-peer network. There's a monetary incentive that rewards the federated servers that are running and anchoring into Bitcoin, right? Because there's a cost for that. You have to pay a Bitcoin transaction fee every time you publish a transaction in Bitcoin. You do that every 10 minutes, means you're doing that 144 times a day, right? So it can add up, like those fees are not insignificant anymore, right? So the anchoring is the publishing of that proof of the whole network over that 10-minute period into a Bitcoin transaction. So you write that hash, it's 32 bytes, and you write that hash into op return field of a Bitcoin transaction. And then you post it to the network and you can see on the Factom Explorer, okay, here's this block. Here's all the data that went into it. Here's the anchor into Bitcoin. I can see that in Bitcoin. I can see it in Factom, and that's how you're connecting the two. So that's how I'm defining a blockchain is the blockchain architecture, a peer-to-peer network, a monetary incentive, the token that really fuels those servers. As far as different blockchains, it really depends on what they're doing. Ethereum is really around smart contracts, Bitcoin obviously for payments and storage of wealth. I think of as Factom as data validation, a data layer for the blockchain. And then you have other groups that are doing raw data storage, like distributed hash tables, like Safe Network and Storage and others. So it all depends on the use case, which makes sense. It's not necessarily, again, that all blockchains can do all things. The truth is they're getting very specialized around different use cases. And so somebody could still build a blockchain and it makes sense if none of the existing blockchains serve that use case, right? But I think increasingly people are building on top of the existing blockchains, right? If you need data validation, don't spend 3 years and millions of dollars doing it yourself. You know, the Factom APIs are right there, like go for it, right? You know, you don't even need anybody's permission. You know, or if you're going to do some smart contracts, you probably don't. You need your own smart contracts platform, right? There are thousands of Ethereum developers. There's a big community there. There's a lot of infrastructure. Just hook it up to that. So I think we're slowly moving past this infrastructure level to, you know, people building platforms and applications on top of this infrastructure.
Okay, so then I guess essentially by linking up with these other blockchains, you're incorporating something that they may be better at doing, you know, depending on whatever your case is, you know, sure, their functionality that they haven't, I guess, developed a little bit more.
And in the case of Bitcoin, it's all the electricity they're burning, right? You know, the proof of work level of Bitcoin is just incredible. We don't need, you know, proof of work miners in Factom where we can inherit all that security from Bitcoin, right? And for Bitcoin, this is a way of people that have been very critical of those publishing directly into Bitcoin metadata or non-Bitcoin transactions. This is a really efficient way to move what they would call bloat from the system into a second layer, right? So a lot of core developers have talked about that, and I think they're generally in favor of using these type of Merkle tree structures as a really efficient way to move non-Bitcoin transactions into a different layer where they're not competing for those fees. And if you think about it, it's a really cost-efficient way to do it too, because if you were to publish in the Bitcoin network and you're paying that $1 fee or whatever it is at this moment, instead, if you have 1,000 records you're publishing to Factom and you only need to anchor it with one transaction, you spread the cost of those 1,000 records over that one anchor. Right, and that's pretty much what we've done. Is we've had 100 million records secured in Factom, and only published those 80,000 anchors. So that's the scale of which we got efficiency. Right, all of those records into a much smaller number of anchors.
Okay, so rather than competing with them to be the master of it all, you
Right.
know, you're kind of teaming up to use that. That's wonderful. Thanks.
Yeah. Cool.
Hi, David. Good evening.
Good evening.
Thank you so much for sharing your knowledge with us tonight. So I think my question is more philosophical. You know, looking at cryptocurrencies, there just seems to be an incongruity to, you know, the purpose of the currencies and blockchain, you know, having stability and verification, and yet the value of the cryptocurrencies, you know, it's all over the place, and the volatility of it. You know, when I look at the two of these two elements within what cryptocurrencies are, it just kind of shocks me, and I'm wondering why there's not a more logical way for me to analyze this incongruity.
That is a good philosophical question. You know, when I was taking economics in school, you know, one of my textbooks described this as a random walk, right? Why is the, you know, price of something what it is, right? Why isn't it more predictable? And I think the best way I've heard this described is the old Warren Buffett quote, which is that on a day-to-day basis, in the short term, the market is a voting machine, right? Everybody shows up and they vote what the price is going to be today. But over the long term, the market is a weighing machine, right? If a company is profitable more and more every quarter, eventually, you know, that will be reflected in the shares in the stock. And so you asked about the utility of the protocols. I think it's very similar. Over time, the protocols that provide more and more value and more utility, that will be reflected in the value that people place on them. So I have no ability, no crystal ball to say what the price is going to be today or tomorrow or a month from now or a year from now. You know, in fact, I would specifically shy away from that because, you know, I have no means or logical way of predicting that. But I would say that my focus is building on the actual utility, right? And if more and more people are publishing more and more documents and records in the network, in the case of Factom, or more people are doing more and more Bitcoin transactions, or people are using more and more smart contracts in Ethereum, I think people will recognize that value over time. But, you know, it's impossible to say what the markets will do. And I see this sort of more from the fundamentals. Is I try to filter out all the noise of what's happening today or this week or this month and just say, I think more people will be using it and it'll be offering more utility tomorrow. And I think that's ultimately what drives things.
Okay. Well, thank you very much.
Sure.
Hi, David. I'm John. I'd also like to thank you for your time today. But when I think of blockchain applications and where that potential value is, my mind immediately goes to intellectual property. And I was wondering if you've ever worked with any governments or businesses on issues like that.
Intellectual property, are you thinking intellectual property created for patents or trademarks or copyright, stuff like that?
All of it, yeah.
It's certainly an interesting application. A lot of people have brought it up before, you know, all of a sudden you could easily prove who originally created something, right? And beyond, you know, sort of more broad ideas, I think this is most useful in the creation process itself. If an artist is creating a song, they could have a complete record, because most of them do it all digital these days. They could have a complete record of how that song evolved, where they're sampling from, the end product, et cetera, et cetera. And it offers a really efficient way of anchoring that in to an immutable record. But I think the big hurdle is to get the studios and the intellectual property owners, which a lot of times are these big companies that aggregate huge portfolios, to recognize that they could create a lot more value for their artists and for their clients if they had those records in a way. A lot of times this is expressed around royalty payments, right? Right now it's like a multi-year process to get paid on, the song was played here or was played there, or so many copies were sent. There's obviously a lot of room for efficiency there. And so I think that could be an interesting use case. A little while ago, I think there was a post, Bitcoin for rock stars, if I'm not mistaken, was the title, and kind of explored that use case. So it's not one of our core use cases that we're focused on, but I definitely hope somebody builds that solution. I think it's only a matter of time. I think we're really in a process of replacing all the world's legacy databases, or at least securing all the world's legacy databases with this blockchain technology. Because especially in the financial world, at some point, not using immutable data is going to become negligent. Like, oh, why didn't you want all those records to be transparent and auditable, right? So I think it's a best practice that's going to emerge, but it'll probably have to be over the next 3 to 5 years.
Thanks.
Yeah.
All right. Well, I guess we've satisfied everyone's curiosity, at least for tonight.
Cool.
But it's definitely great having you have a chat with us, David, and got, I think, a lot of people from a lot of different backgrounds here who are just interested in starting to dipping their toes into this space. So is there anything in particular that we should be on the lookout for from Factom? Basically, you're doing more rollout of Harmony, or is there anything else big on the horizon?
I'll just say that things are going well, and that we're working with more partners, and that we try to let them do the announcements when they're ready and in their time, so that we don't get ahead of things, is definitely one of the things we've learned. And so I'll just say that for Factom, what gets me most excited is this idea of scalability, right? Because that's been one of the core things we've been debating and trying to figure out in the blockchain space the last 2 or 3 years. And Factom offers a truly scalable data layer, right? So if you have a use case that needs millions or billions of records secured, this is something finally that lets you do that. You don't have to wait till blocks get to a gigabyte each, and you don't have to wait for the Lightning Network or other systems to come online. Factom is in production today, and that's pretty cool. And I'm really passionate about decentralizing everything, and I think if you're going to get there, you have to have a scalable data layer that works for large use cases. Because we're really talking about taking all the world's data and putting it on blockchains. You have to do it through technology like Factom. And just to exemplify the scalability here, in a Merkle tree, it's exponential, right? You can, at every layer, it's 2 times as much. So, in one Merkle root, you only have to go 20 layers up to get to 1 million data points. If you go 30 layers up, you're at 1 billion data points, right? If you go 40 layers up, you're at 1 trillion data points. And you can still take just 40 points of data and get all the way down that branch and prove your particular piece of data and ignore the trillion other records, right? So that's the level of scalability that we're talking about. This is not linear. This is very exponential. And so I'm excited about it because it brings things into the real world where I've been nerding out and imagining since 2012 when I got into Bitcoin that we're going to use it for X, Y, Z. But until you had a solution that really scaled to that level, that remains, an idea or a concept or a proof of concept, right? So I'm all about bringing this practically into reality and doing it today. So that's what gets me really excited about this. And yeah, we've just been so fortunate to bring on these different subject matter experts and people who have joined the Factom team. We're at 35 plus people at this point working full time on Factom. So it's been pretty incredible. And just the internationalness, right? We were translated into the Chinese, the white paper, immediately. About half of our usage comes out of China, right? We've got a huge community there. We have an office in Shanghai. I go there 4 or 5 times a year. Investors there, friends there, developers there. So, this isn't just happening in Austin, Texas, or in the US, but it's really been a global thing. So that's been pretty cool to be involved in something that's worldwide. So anyway, but yeah, really cool to talk to you guys. Thanks for the opportunity to just speak more about what we're doing, why we're so passionate about it.
Yeah, thanks.